I'm Eric Siegel, CEO and co-founder of Gooder AI. In this video, I'm going to show a demo of Gooder AI. We're going to strike a careful balance between competing KPIs, and we're going to see how various business factors affect the calculations of KPIs so we can interactively get an intuition of the degree to which their uncertainty actually matters. So here we are for payment card fraud detection. This is the savings curve, and we'll show some of the other charts as scroll down later, a table of some competing KPIs. Now we're going to zoom in because if we're doing payment card fraud detection, the bank is only going to automatically block as potentially fraudulent some very small percentage or maybe even less than 1% of fraudulent transactions, depending, and this is going to help them navigate that decision. So from left to right, most likely to be fraudulent down to least likely. This is comparing three competing models, a random forest model and 2 XGBoost. This is the decision boundary. So it's saying, hey, look, if I stop here, the best of the three models is estimating to save us $16.9 million as estimated over a potential population of, let's say, 10 million transactions over the next quarter for this medium-sized bank. And that calculation depends on these factors in the bottom I'm going to change. So let's go to the peak of the curve and see where our potential best bottom line monetary savings is. Go to maximum value. So it's saying with that best of the three models, $22 million. Now, that depends on a few things. So it depends on the position of that decision boundary, of course. This would be blocking 3%, which is sort of a lot. We might not want to block that much as a bank. It kind of disrupts commerce. And it depends on these factors. But before I get to these factors at the bottom, let's just navigate between this monetary bottom line and one of the competing KPIs, which is the number of false positives, the number wrongly blocked. So for that particular best model, if we drew the boundary here at 3% and block those top 3% of transactions most likely to be fraudulent according to that XGBoost 1 model, that would mean each quarter, if a quarter had 10 million transactions, the absolute number of wrongly blocked transactions, that is legitimate cardholders trying to do business, buy their product or use their card, 86,661 times they would be wrongly blocked. They'd be inconvenienced, right? Now that costs something. It definitely hurts their experience. That cost is already incorporated. The second of these two sliders down here is right now set at $75. And I'm going to come back to this, right? We can interactively change that fact that is a value that might be subject to change or uncertainty. But if it's fixed at an estimated $75, because this inconvenienced cardholder is going to potentially stop using the card as much, or even cancel it entirely, start using other cards in their wallet, or what have you, happens, especially if they're subjected to it repeatedly. So on average, it's costing the bank an estimated $75 each time that happens, and that cost is already incorporated into that first row business metric of monetary savings, which is the same metric that's actually being charted in this main chart that we're looking at right now. So it's already been taken into account, and yet the bank is still going to potentially care about the absolute number because there may be sort of intangible negative detrimental effects of it, right? It's a perceptual thing. It could have longer term detrimental effects that are not included in that $75 estimation. It's just a disruption of commerce. So we care about it as a competing KPI in and unto itself, in addition to also caring about the monetary bottom line of how much we're saving, right? So a savings curve and a profit curve aren't that different, right? Because if you save $22 million, a penny saved is a penny earned, right? So there's just some semantics with the words here. So the $22 million things, that sounds pretty good to me. But if you look at the curve here, it's really quite flat. And that's a signal that we could potentially move our decision boundary further to the left. And instead of blocking 3%, if we go over here and we've only sacrificed $1 million, went down from 22 to $21 million, but we have more than cut the absolute number of false positives of wrongly blocked transactions down to $1,000. So this is one of the reasons in general we want to use charts, that is to say curves rather than tables, and want it to be interactive and be able to move things around and see that. But let's look at that same thing I just showed you. Let's look at it actually. Let me put my money where my mouth is. Let's actually do it visually, because this metric of the absolute number wrongly blocked is also one of the charts here. Here's a gains curve. This is typical technical metric, response deciles. This curve over here shows the relationship between the decision boundary, which is the proportion treated, versus decision threshold, which is the probability threshold on the output model scores. They have a direct relationship, and that's covered in a different video. And here's the number wrongly blocked. So first of all, I'm going to make some room for it so we can put these two charts right next to it. And then I'm going to just drag it up here. And I'll zoom it in because right now they're not very in sync. So let's zoom it in a bit more. Okay, so what I was just talking about is this sort of flat region here over on the left. So as I move the decision boundary, looking at the chart on the left, I'm moving within a range where the vertical position doesn't change much. That is to say, the amount being saved, you don't sacrifice very much as you go to the left here. So within that range, now look what's happening on the right within that range. It's almost linear, and it's almost at a 45-degree angle. And just to be clear, we're talking about the lowest of these three, but they all have a similar angle in that one, because that's the chart XG1 boost. That's the model XG1 boost that we're talking about. So the same point I just made, we can move to the left, sacrifice just a little savings, and as we're doing that, as we go to the left, if you look at the right chart, look how quickly you're going down in terms of the absolute number wrongly blocked. Okay, next point. Let's talk about what these two sliders do. These are the business factors, and you can configure this to include any and all values that might be subject to change or uncertainty, and that are part of the arithmetic under the hood that you can also configure. That is the calculation of this KPI of savings. Well, every time you miss fraud, it's a false negative. You let fraud fly, that costs you something. Usually it costs around the size of the transaction. So a $100 fraud isn't nearly as bad as a $5,000 fraud. So you can think of it as the false negative cost, or conversely, the true positive gain. That is to say, every time you correctly identify something that will be fraud and therefore block it, so everything to the left of the decision boundary that actually is blocked and actually is fraud, you've actually gained or saved the amount of that transaction. But is it always 100% of the transaction that the bank would lose if the fraud flies, and that therefore they would save by not letting it fly? Well, not necessarily. There could be some kind of insurance policy that covers some of the exposure due to fraud. Also, there could be downstream operations. Even after a transaction has been authorized, there would be certain investigation and enforcement where some of the money is recouped. So let's assume for the moment that actually they don't have to pay the full 100%, the $100 or the $5,000, but really just 85% thereof. So the fact is, those are the kinds of factors that may be subject to only estimation or Fermi estimation, guesstimation if you want to call it, uncertainty, or intentional change in the future somehow, or expected change. So you can interact with them. So that's one of the main purposes of this software solution, is that because you can interact with them, you get that much needed human intuition about how it changes the shape and of the curve, the location of the peak, the height of the peak, etc. So if it's at 85%, let's go to the max value. Okay, well that's telling us we would want to block the top 2.75. Before we were up close to 3, so it's not a huge difference in where you would want to position the decision boundary. So that's kind of nice intuition or insight that we get right then and there. It's saying, look, we might have this uncertainty range of between about 85 and 100% as far as the amount we're liable, proportion of fraud that we're liable for as a bank. But it doesn't make that huge of a difference as far as the fact that these models look good, we know which model to deploy, and we know something of a limited range of where we should draw that decision boundary. If we go to the maximum value, we're already at the maximum value, right? And we also can see that the max has decreased from 22 million down to almost 18 million. So it decreased by 4 million. Why did it decrease? Well, if fraud costs less, it only costs 85% instead of 100. That means we stand to lose less from fraud, and we stand to save less with fraud detection or fraud prevention. So all of a sudden, fraud detection becomes a little bit less valuable, but that's fine. We want to know the truth, and that, again, doesn't make such a huge difference as far as our business decision of which model to deploy and how to deploy it. Finally, let's go down to this other one that we talked about a couple minutes ago. The cost of wrongly blocking, that is the false positive cost every time you inconvenience a cardholder. Well, you could change that so that it's actually related in some proportionate way or somehow related to the size of the transaction. That would be one option. But in any case, right now it's configured here to be a flat amount. And as a bank, you might say, well, look, it definitely hurts the customer experience, and that turns into a monetary loss for us every time we wrongly block a transaction. Maybe we can ameliorate that by proactively offering an apology gift card of, let's say, $20 or $10, let's say, every time we do that to a customer. And we're like, sorry, we understand that was inconvenient. Here's your $10. That's going to be kind of a complex, costly operation, not to mention the cost of the gift card itself, but it might be very effective psychologically. And maybe it would actually decrease the net cost of every false positive, every wrong blocking from 75 down to $50. So is that good? That sounds like a pretty optimistic scenario if it really had that much benefit. But if it did, what would that mean? Well, let's go to the max value. Well, it would mean a pretty big change to the decision boundary. It would be suggesting that we block even more. Instead of less than 3, it's now more than 3.5% of transactions, those most risky to be fraudulent, to maximize the bottom line savings. It's also saying that our savings would increase, indeed, net savings, because those false positive costs wouldn't add up to as much. But not that much, right? From 22 million up to 24.5 million. So when you think about it, if that's the most sort of a very optimistic scenario, probably, if that's what our intuition is telling us, and it's only giving us potentially a relatively small amount, it's very complex, there's a lot of uncertainty, you might as a bank say, okay, well, this is giving me an insight. It's probably not worth, no other bank is doing this. It's not even worth the cost of trying that out and seeing what the upside might be. Forget that idea. Let's table it. Let's talk about it next year or whatever. Okay, so that's it for the demo. I'll just tease something that's in another video, which is that you can do something which is called expected value. And if you decide based on expected value of blocking a transaction rather than just the pure risks or the probability, you get this. If that looks enticing to you for a variety of reasons, it most certainly is. I go through what that means, how to do it, and exactly why it's enticing in another video on expected value that we'll link to in the description of this video. In the next video, we'll cover how to get started hands-on with Gooder AI.